Welcome back to the HVDC Offshore Platform Learning Series. In this video, we're going to explore the complete workflow of design drawings for an offshore HVDC platform using Tekla Structures. This includes the types of drawings we produce, what is not part of our scope, and how these drawings progress through FEED, DNV, IFC, AFC, SQ, and finally SDC. Let's begin by looking at how Tekla fits into offshore HVDC projects. Tekla Structures is the core platform used to build the 3D model of the structure. From this model, we generate all essential design drawings for engineering coordination, client review, and approval. It becomes the foundation for all structural and interface decisions throughout the project. Before we continue, let's clarify our scope. In this series, we focus only on design drawings, the drawings used for engineering and approval. This includes general arrangement drawings, plot plans, sections and elevations, structural typical details. We do not cover assembly drawings, single-part drawings, or fabrication shop drawings, because these are prepared later by the fabrication yard. Our responsibility is the design intent, not workshop production. Now let's go through the types of design drawings we produce. The most important are the general arrangement, GA drawings. These drawings provide the complete visual representation of each deck, its structure, framing, equipment rooms, access routes, penetrations, platforms, ladders, and interfaces. Within the GA package, we also include the plot plan, which is especially crucial in the early stages. The plot plan shows equipment locations, operational zones, hazard areas, safe access, escape routes, and maintenance clearances, because an HVDC platform contains converters, reactors, transformers, HVAC equipment, and multiple rooms. The plot plan ensures everything is positioned safely and logically. Next, we prepare structural typical details. These drawings standardize repeated structural connections, stiffener layouts, support types, and deck penetrations. They ensure consistency across the entire platform and reduce ambiguity. We also produce key structural sections and elevations, which cut through the platform to show vertical alignment, framing interaction, and space allocation for cable trays, ducts, and mechanical systems. These sections make it easier to coordinate with electrical and mechanical teams. Once the initial drawing package is ready, we move to the first submission. This early stage package typically includes a stable Tekla model with main structural components, GA drawings for all decks, sections and elevations, structural typical details, plot plan, preliminary equipment layout, member identification and major load-bearing structure, weight summary and center of gravity estimation, a complete material takeoff, MTO, with steel tonnage, plate weights, and deck-by-deck summaries. This is usually issued as issued for FEED or issued for review. Now let's go through the official approval stages. The first step is FEED, front-end engineering design. At this stage, drawings focus on the high-level concept. They capture the overall structural arrangement, the load paths, and the main engineering assumptions. FEED drawings help confirm that the design direction meets the project requirements. Next is the DNV review. DNV is the verification authority for offshore structures. They review the drawings and the model to ensure compliance with offshore codes, structural strength requirements, safety rules, and design principles. Comments from DNV must be resolved before moving to the next stage. After FEED and DNV, the drawings are issued as IFC, issued for comments. IFC is a critical step where the client, interface teams, and other stakeholders review the drawings and provide comments. This ensures all disciplines are aligned, no clashes or layout conflicts exist. All structural, mechanical, and electrical requirements are met. The platform design is complete and ready for final approval. IFC drawings often go through several rounds of comments and revisions until all issues are resolved. Once all IFC comments are closed, the drawings are upgraded to AFC, approved for construction. AFC drawings represent the finalized, client-approved design. These are the official drawings used by the fabrication yard to build the platform. They form the technical basis for workshop drawing development, procurement, and fabrication planning. During fabrication, the yard may raise SQs, site queries. These arise when clarification is required for dimensions, tolerances, alignment, missing details, or conditions encountered during assembly. SQS may result in clarifications, sketches, or updated drawings. Finally, if any modification to the approved design becomes necessary, an SDC, structural design change, is issued. An SDC may be triggered by updated load requirements, revised equipment positioning, fabrication or installation constraints, tolerance issues discovered during assembly, changes requested by the client, DNV comments during later verification steps. The SDC formally updates the AFC design, ensuring the actual built structure reflects the latest approved engineering decisions. All SDCs are controlled, documented, and integrated into the project's design history. So this is the complete workflow of design drawings for an offshore HVDC platform, from early Tekla modeling, GA drawings, plot plans, and MTO, all the way through FEED, DNV, IFC, AFC, SQ, and SDC. Thank you for watching, and I'll see you in the next video.